It was brought to my attention that Anycubic was having a sale. Their Anycubic Mega Zero 3D printer was on sale for like $140. I found it for $150 off Amazon. And I was like, I cannot resist. I have to buy this thing and see how good it is or how not good it is. Some friends of mine have Anycubic, but I think they've got like the bigger one. So I'm just kind of curious to see in this day and age what a $150 printer is like. So let's open up the box and see what's inside. Ah, looks like there's a bunch of instructions and parts on the top of the unit. Oh no, this is the control panel. Oh, that's pretty cool. It's got a dial. I assume this is probably like a OLED or an LCD. That's not bad. Looks like it's pre-connected to some of the rails. Interesting. I mean, obviously I knew this was going to have some assembly required. Oh, so on my back porch, instead of my furnace, you get to hear my ceiling fan. All right, so this has extruded aluminum square channels. I believe that's also what it uses for some of the rail guides. And, okay, so this is probably going to be your Z lead screw. In fact, there's nothing else it could possibly be. Let's see what we got. Oh, some test filament, it looks like, and a USB cable. Oh, it even comes with a micro SD card. How nice. Not a very big power supply. That's it? What's it say? 12 volts, 6 amps. That's a bit wimpy. Oh, you know what? I believe this unit doesn't have a heated build platform. That probably saves a lot of power. All right, power cable. What is this? It's like, oh, this is probably a spool holder of some kind. Oh, just what I needed. Another putty knife. Now I can redo the drywall in my bedroom. Let's see. Oh, this is probably the extruder gearbox, if I had to guess. So this is not going to be on the print head. This is going to be somewhere else in the unit, if I had to guess. All right. Then we have... Oh, that stepper motor has... Oh, this is probably for the filament extrusion. If I had to guess. Oh, yeah. See? That's going to go. Figured it out already. Oh, yeah. Then you'll attach 3 screws. I'm way ahead of you, Anycubic. This comes out of one piece. Oh, okay. So this is going to be your X carriage. Come on. Ah, there we go. Yeah, well, that's nice. This is all pre-assembled. Oh, okay. I don't know. Yeah, can you see? Oh, yeah, you can see this on camera. So that's going to be your coupling for the Z-axis lead screw. It looks like the extruder is basically all one module. They've got everything pre-wired up. I think what happens is these wheels ride in the channel like that. Not really the best solution, but again, $150. Oh, Mega Zero. That kind of sounds like an oxymoron. I'm guessing these are going to pull out. Yes. To reveal the base. Oh, there's your Y limit switch. And then the double aluminum extrusion. Yep. It behooves a company to make the product box as small as possible. Shelf space and all. Or in this modern age, Amazon space. Because fun fact, when you have something fulfilled by Amazon, they actually charge you a little tiny bit of rent for their warehouse. Oh, well, it's nice that that's all in one piece. Jeff Bezos comes up and he's like, rent! Sorry? What's sorry? Can I spend it? I'm Jeff Bezos. I'm Jeff Bezos. I wonder if people realize Amazon is just the next Walmart, which was the next Sears, and history just repeats itself endlessly. Oh, look, it's got these wheels here for, I don't know if you can see the wheels? That's it. Look at these big fat wheels for adjusting. Oh, well, I just generated some current there. Big fat wheels for adjusting the table. So yeah, it's not heated, which means you're going to be looking at PLA. It is kind of crooked if you look at those wheels, but we'll dial it in later. 8mm rods. Let's get this accessory packet out onto a tray. Nice! I know people love it when I impersonate that channel. Oh, it comes with a free credit card. What is this? Wow! Oh, it's a It's a micro memory stick reader. I thought it was a free USB drive because, you know, I obviously need more of those. So we got our mounting hardware here, all metric. Second cap, another limit switch, USB cable. Obviously I'm low on those. 8 gigabyte completely generic SD card. Oh, look at all the tools we could possibly need. Oh wow, look, it came with flush cutters for cutting the filament, I assume. For all 0.0000% of households that don't have scissors. We got a variety of Allen wrenches. It's nicely labeled, it says exactly what it is. It's not stuck in some crappy IKEA blister pack. You know, I've actually never been to IKEA, but I've certainly bought crappy furniture before. Step 1, install frame. Install the aluminum beams to the base. Okay. Okay, I believe that's going to be these. So that's going to be a M445. Oh, okay, so it's M4 size, 45 millimeters long. Okay, so the one that has holes in the side, this goes over here. And the one without holes goes over here. All right, you can find those parts and I'll do that up. My Bonnie lies over the ocean. My Bonnie lies over the sea. My Bonnie lies over the ocean. So bring back my Bonnie to me. Bring back my Bonnie to me. Bring back my Bonnie to me. From the creators of Aliens the Musical. So someone said Bob's Burgers already did Aliens the Musical, so is Bob's Burgers the new Simpsons did it? At any given time, there can only be like one hot animated show, right? So like first it was The Simpsons, then it was Beavis and Butthead, then it was South Park, then it was Family Guy. I suppose now it's... Is it Rick and Morty, or is that already done? I don't know. Let's see, what's next? I have to go, well I don't have to go, but I'm gonna go watch Tenet in a few minutes here in theaters. Screws or holes here is for mounting the Z drive motor, which looks like it's this one. Yes, all right. Blah, 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 blah. Okay, M4 by 25. Here we go. The motor cannot tilt. No, that's incorrect. The motor shouldn't tilt. Install the Z coupler to the motor. Okay. Looks like there's some grub screws and then the adapter. It's pretty simple stuff. Who's Snow White? Apparently she's some sort of consultant. She saw an alien once. So I'm gonna put it onto the shaft. I'm gonna tighten one side, then I'll just rotate it because I don't know, it's good to have one of the set screws on the shaft side. Now I must install the X module. Welcome to Die. Alright, so I'm assuming that this just goes down. Yep. Okay. Alright, and this should engage into the drive nut. This should lower. Oh, come on. There we go. Well, anyway, I'm going to move on to the next step. But that was quite easy to install. Much easier than installing the X axis on my big CNC machine. But yeah, see, we just got these wheels here that are going into the grooves, but there's a pretty good grip on both sides. And you have that on, well, both sides as well. So it's actually pretty solid. I made a mistake. I put this one on backwards. There's supposed to be some screw holes here for the Z limit switch, right? But they're on the other side, so great. I've got to reverse this beam. Now, since I had to take everything apart, flip the beam around, I'm gonna do something a little different from the instructions. I didn't tighten up this motor quite yet. I'm gonna put the Y carriage into place first. Okay. And I'm gonna okay. Now with that in place, now I'm going to tighten this. So it basically had some kind of pre-reference, basically. Now I can go in and attach the Z limit switch, which I believe goes right here. Okay, now I must install the extruder. So it looks like it sandwiches around this with the M3x38 screws. And let's see, it wants the power cable going out the back. So I believe, yeah, like that. Okay. No problem. Oh, this must be the tensioning arm. Yeah. So it's kind of like a Bowden tube, right? It just doesn't go that far. I mean, a lot of times when you have this kind of extruder, it'll be down here and there'll be a long path up here. But yeah, this looks pretty good. I like the fact the extruder's all in one piece. We don't have to mess with it. It's just, you know, already set up. Time to install the top aluminum beam, which I guess is this thing. Probably noticed that the lighting changed. I went and watched Tenet. Did not like it. Very obtuse. You ever see that movie Primer? That really low budget time travel movie that a couple guys made for like $16,000. It's Primer with guns, basically. But I'm sure Christopher Nolan fans will watch it like 100 times and make, you know, complicated diagrams on the internet explaining everything. Oh, who am I talking about? The movie's been out for like 2 days. Those diagrams probably already exist. You know what? I'm gonna just overlay one on the screen because I'm so sure they exist. I'm just going to assume they exist. And when I edit this, I'll just put it in. Oh, I see. They don't have recesses for these like they did on the bottom. I guess it doesn't really matter because these things aren't having to sit flush against a table. I don't know, what is Christopher Nolan's thing with masks? I guess he was ahead of his time, but he's like, oh, all my characters must wear masks all the time. Imagine a movie full of Banes. And that's Tenet. It's like, blah, 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 blah. All right, got that. Install the filament holder. Assume that's this thing. Oh, but Ben, you just didn't understand the movie. Blah, 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 blah. Oh, okay, yeah, it goes on the top. Oh, okay, so the filament goes here. That makes sense. Seriously, you get to the last scene of that movie and you've got like hundreds of people running around with gas masks on, talking, and it's like, what is going on? It's like, blah, 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 blah. All right, so I got to use this T-nut. T-nut is a kind of nut that actually slips into a channel, so it's probably going to go into, I'm going to guess, the lower channel. Yeah, looks right. Come on, get in there. Oh, that's why they have a cap missing here, because that's where the control panel attaches. All right, now I'm supposed to hook up all the wiring. Okay, oh, that's the Y limit switch. All right, so this is going to be the Z, I suppose, because it's close. Oh, that's actually pretty nice. He's got these little clips that just go onto the snap action switches. Probably put some zip ties on this after I'm done. And, oh yeah, you don't even really need to think about it. Look at this, it's like, this is obviously the Z motor, yep. Well, as long as this wheel clears the switch, we should be okay. Yeah, I'll just zip tie it down. Kind of stating the obvious, but when you're doing a printer like this, once you start hooking up motors to the control box, don't move the motors too much, because what you'll end up doing is you'll be generating current and sending it back through the circuitry, kind of in an uncontrolled way. So try not to do it, or if you do it, move them slowly. It says to switch on the printer, then tighten the 4 adjustable nuts underneath the printing platform to avoid the printhead hitting the printing platform when homing. Kind of obvious. Looks like the back side of this is all getting started from an electronic standpoint. All right, let's turn it on. And it's kind of a, well, it's a single color dot matrix display. Oh yeah, so it's probably using kind of like a clone of like the LCD 12864 that Marlin uses. Yeah, there's a part cooling fan. So this is the main, basically to keep the extruder cool, but then this is going to be blowing onto the part. There's the nozzle, pretty standard heat block around it. I like these big wheels. Big wheels keep on turning. Proud Mary keep on burning. So I'm going to tighten these wheels all the way. And then I assume what I'm going to do is I'm going to bring the plate up to the nozzle. There you can see my bald spot very easily. Leave a comment below telling me about it because I'm completely not aware about it. Home all, okay. All right, let's try it. That's pretty slow. Well, I think we're gonna go make a sandwich. Was that gonna hit the wheel? That's kind of lame. It looks like the nozzle is just above the surface, so what you would do is you would then use these knobs to raise the bed up to the nozzle. I think what I'll do, since it is above the surface, I'm gonna go ahead and tighten up these Z-screws. And now that I've tightened up the Z-screw, I'm going to rehome it. Oh, so I'm gonna prepare. Be prepared! Dun, 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 dun. Off and on. Okay. Yeah, it looks like we're about 1.5 millimeters above the surface. That's good. Okay, blah, blah, blah. After home, press the knob on the screen, navigate to prepare level corners. Okay, great. Be prepared. Hey, I know, let's remake Lion King and not have the song Be Prepared in it, the one all the millennials like. Blah, blah, blah. Okay, so basically it wants me to manually level this with the knob. So I'm actually going to go get my leveling piece of plastic that I use on the Maker gear for this part. All right, so I'm going to put my blue piece of plastic under here, and then I'm going to release this knob, which will make the bed go up. So I can feel a little friction. My rule of thumb is just enough that you can still push it back in, right? Because if you go too tight, here, let me show you. If you go too tight and you can't push it back under, I think that's a little much. So yeah, I tend to, you get just to the point, yeah, that's a little too far. Yeah, that's good. Okay, I'll do that for all four corners. You know what this movie needs? What, Mr. Favreau? Less Jeremy Irons. You're right. Every movie is better with less Jeremy Irons in it. Said no one ever, except Jon Favreau. Prepare. Preheat PLA. Oh, you hear that? The fan reduced in frequency. So, what are these for? Okay, the PLA is almost at temperature, 190 Celsius. So I'm going to take, this filament feels really weird. I don't know how to explain it. It's like very light. It feels like plasticized cotton candy. I'm just gonna wing it now. Thing is, can I get past this if I pull this lever? Oh yeah. If I pull that lever, it disengages the gear, which should allow me, no, never mind. So that's where the tooth gear is gonna be, but if I pull this out, pull this part out. Come on. Oh, I see, I'm missing, whoa, it's like a slinky. Come on. Okay. Why? Oh, is it hitting the side? The plastic is hitting before this nut. That's not cool. There's the filament. Yeah, see how, obviously, you know, since the filament is round, it's going to have kind of a spring quality to it. So if I push it through now, yeah, see that? That curl. You know what? I'm just going to get a different filament because this filament, not only is it weird, it's also wound more tightly, like my blood pressure. I've had some good luck with this GE Tech printer filament. See, this too is bumping into something. All the while the nozzle's like, gonna use me or what? Okay, there it goes. So yeah, this might not be the easiest thing to load. Of course, I could always, you know, tear it apart and make my own. That's actually been a big thing, like for me, like when I make a custom 3D printer, it's like, how easy is it to load? So this should go until it hits the hot end, in which case I'll feel friction, and then if I push, there's the extrusion. All right, let's see if we can do a manual extrusion. Ooh, wow. Look at it spit out that filament. Woohoo! All right, well, don't need instructions anymore, all set up. All right, I guess Oh, is there an Anycubic? I think I have Simplify 3D on my laptop. I could try finding an Anycubic. I know they have, Anycubic's a pretty popular printer. I don't know if they have Anycubic Mega Zero, although it really shouldn't matter. It should just basically take whatever zip code I give it. Did I say zip code? I meant G code. Zip. Zone Improvement Plan. Mind blown. All right, Simplify 3D. Let's see if I can add this. Anycubic i3 Mega. It's probably close enough. Oh yes, mini USB, my favorite. Depth to USB micro and what's the other one called? C. All right, USB serial channel 34. Oh man, yeah, this must be using like old school like FTDI type serial converter. Oh no, connection failed. Huh, maybe I can't talk to it with this program. Maybe what I can do is use this really cheap converter device they gave me. Maybe you need like your own software for this to work? I don't know, but of course Anycubic was listed as it was listed as one of the printers. Okay, Anycubic i3 Mega. Yeah, that's exactly what this is. Can't be that much different. Prepare to print. And I'm going to save toolpaths to disk. I mean, normally I print over USB. 20mm box. Okay. Bada boom, bada bang. Assuming my settings are close enough. I think Spooky Pinball has some of these Anycubics. They have like slightly bigger ones, not this. Is it going to Z? Come on. Oh, there it goes. Give us any chance, we'll take it. Give us any rule, we'll break it. We're gonna make our dreams come true. Doing it our way. That also took place in not Madison, in Wisconsin. So I believe this is normally like $170, but it was on sale on their site for $140. Amazon was $150. Obviously Amazon is the easiest thing to use for ordering. So still, I mean, if this is even a halfway decent sub $200 printer, that's pretty remarkable because it wasn't long ago when like sub $200 printers, I mean, they existed, but they weren't very good. This thing isn't super fast. I mean, it's all right. It's probably like, I don't know, 5,400 millimeters a minute if I had to guess. Let's take a look at the pattern on the inside. Come on. That's not too bad. I don't see any obvious under or over extrusion. Looks like it's finishing up now. If you look though, the layers are kind of inconsistent. That's probably a byproduct not having the right drivers. I'm gonna go on their website and see what I can find. Yeah, it looks like they recommend using Cura on their website. I'm so used to the build platform being hot. Let's see how well this releases. Not very well. I guess that's why they gave you a spatula. Now again, I could adjust this by kind of weakening the first Z layer. Oh, what I really need is some pliers. Let's try these. Oh, that wasn't too hard. Pretty good surface, but yeah, if you look at it, see like the, I don't want to call them oscillations, but I think the Z setting is off. So we need to get the right printer settings, and that's why we're going to download Cura. Oh look, Cura has Anycubic Mega Zero. Yay! I was kind of worried that Cura, Ultimaker Cura, would only work on an Ultimaker. Apparently Cura hired that guy or something. Okay. Oh no, Marketplace sign in. Oh, bad bombing. Can I connect to my printer? How do I do monitor? Okay. Can I jog? Oh, there we go. We are connected. Print via USB. Cool, that's exactly what I wanted to do. I'm going to print the same thing I tried to before, and hopefully it's better quality. Looks like it's printing nicely. We'll have to compare it to the first cube in a brighter room once it's finished. Then I will print the good old 3D Benchy ship. All right, here's the Cura print. As you can see, the walls are much more consistent. There's a little bit of, actually a lot of smushing at the bottom, so I believe I probably made the Z a little too tight, but you know, again, I can just adjust that with the knobs. Oh, it's getting dark out here. Okay, I re-Z'd it using a business card, which is obviously a lot thicker. Maybe it's too thick. But anyway, I'm gonna try a 3D benchy. We'll see how the first layer sticks, and if it sticks okay, we'll let the whole thing print and then compare it to some benchies I've done on my upgraded FlashForge printer. Now there's the text at the bottom of the benchy. That's a good sign. So far it's decent. It's not perfect. As you can see, there's a kind of a line there, but you know, so far so good. Overhang's not bad. Power brick is a bit warm. It's probably, oh, I don't know, 115 Fahrenheit. This is certainly slower than my other printers, but so far it's looking good. I like where they put the spool. I mean, I normally build custom rigs to put the spool above anyway and come down. It seems like it's the best way to do it, and also these blinds are terrible. One thing I've noticed about this is that even if you're at the far forward or far rear extremity of the y-axis, the build plate itself never actually goes past the edge of the base. That's nice because then you don't have to worry about things bumping into the build plate. Like if you had your laptop like sitting right next to it like that, it would still not be a problem. So I kind of like that. It makes it easy to figure out where the build plate's going to be, and that's something that doesn't really happen with my Maker Gear. I mean, Maker Gear is a really good printer, but the build plate kind of goes beyond the footprint of the machine. So, I mean, this machine has kind of a fairly large footprint, but you know, at least it's consistent. It's like, this is how much space the machine's going to take, period. You know, there's no guessing about what it's going to hit. So I kind of like that. The first layer, there's hardly any squishing going on, so it looks like re-Z'ing it with a business card versus a thin piece of plastic. It's probably a good idea. 75% with 1 hour 23 minutes elapsed. I wish it would tell us how much time is left. Maybe we could make a program, create new. What are we gonna call it? We're gonna call it printer. Where's the P? Let's see if I remember how to do this. Display. Oh wait, no, I think there's a way to do this where you can, here, let's go program. Oh, no, crap. Turn off alpha. Program. IO, input. I think this works. Input elapsed. Close it. Let's see if I remember how to do this. Comma. I guess we'll just use E. What we're gonna do. Input. Percentage. I'm sure this is what everyone wanted to see. Elapsed. Now this would be 84 minutes. Percentage. 79%. Okay, we've got it entering the numbers. Now we just have to calculate it. What would that be? Oh, it'd be time elapsed divided by percentage. Sorry. Okay, and then you would take that minus time elapsed, and that would give you time remaining. All right, cool. Elapsed divided by percentage store in T. All right, and then display is, I'm just going to assume I can do this. T. Let's see if it works. Okay, elapsed, well now it's basically 90 minutes. Percentage, 82. Oh no! My display thing didn't work. I bet that's exactly... What? P equals P divided by 100? Why is that not working? Oh, because I did it backwards. It's P divided by 100 store into P. Elapsed, 90 minutes. Percentage, 83%. Time left. Oh, I forgot to subtract it. That's the total time is 108. Time left would be total minus elapsed. I actually made a program just like this on one of my other pocket calculators. Okay, we're at 91 minutes elapsed time. Percentage is 83%, which means we have 18 minutes to go. Hey, I mean, there was nothing else to do while I sat here and waited for this Benchy. And you know I love me and my TI calculators. Alexa, set a timer for 18 minutes.
18 minutes, starting now.
Yes, I have one of those things in my back porch. And no, I'm not sorry for triggering your Alexa. Alexa, play the Downeaster Alexa by Billy Joel.
The Downeaster Alexa by Billy Joel on Amazon Music.
Oh yeah, so some people said in the comments, apparently this does use a Z80, but it's the modern EZ80 Acclaim, which is more modern, but it's backwards compatible, which makes sense because then they would have access to modern peripherals such as this LCD and the Quad Spy flash, while remaining backwards compatible with 30 years of TI code. Alexa, stop! Hey, time estimate was pretty much bang on. Nice! Let's see how this removes. Let's get this off of a tray. Oh, that was easy. Oh, or I could just look at the Kira window to see how much time remained. Well, hey, but that doesn't work with the SD card mode, so it was totes worth it to write that program. Okay, now I'm going to print this tall, thin tube to see how consistent it is. Probably notice there's a seam on the back. That's where the layer change occurs. See that? That's where there's extra plastic there. But that's okay. Some slicers randomize that. This one obviously doesn't. Print that tube. Squish that cat. Hey, now it's daytime. All right, I've got my Harbor Freight square. A little deviation. I don't know if you could even see it. Maybe I gotta get a better camera angle. Oh. 0 production values. Let's see if you can see my skin behind. Oh yeah, you can kind of see my skin behind that. Well, let's check the other side. Yeah, it looks like it is a little off in that direction, but you know, all things considered, not too bad. Again, $150. Oh no, I made a giant straw. Don't tell California. And now I'm wishing I would have printed in a more neutral color, such as gray. It'd be easier to film. All right, well, let's examine this tube first. It has a line down the back. Kind of reminds me of the Depression when women would draw a line down the back of their legs to make it look like they could afford stockings. Well, I mean, I wasn't alive during the Depression. The first Depression. Let's see if we can get a focus on this. Of course, I can always zoom in using the 4K. All right, yeah, so this printed what you would call vase mode. Basically just printed a wall on the inside and the outside. Printed, well, pretty quickly, obviously, for the printer. Because of that. Let me get my magnifying glass. All right, I have to kind of look at this in a way that really can't be shown on camera. Oh yeah, the layers are really consistent. And, you know, obviously the seam is a bit unsightly. That happens because that's basically where the layer changes, so a little bit more plastic tends to end up there. They could probably improve their retraction settings. That's basically where they pull the plastic out of the nozzle so it doesn't, you know, basically drip. Down here, this was the print end. And there's a little bit of squish, but it's not too bad. You pretty much have to have some, right? Unless you've got a lot of glue on your table. You have to have some, otherwise you're not going to have good adhesion. And really the most important part of a 3D print is, you know, adhering to the bed. Let's see how much deviation we have. I believe this was supposed to be 3/4 inch. All right, so it's supposed to be 3/4 inch. And let's make sure we're not on the... It's about 0.73. All right, let's see if it's consistent. It's a little lower at the bottom. So it's a little low, however, that could be due to the fact that it's mostly hollow, so it might be cooling and contracting upon itself more than it would have if there was some sort of internal structure. Let's see what we have for the... Oh yeah, so the first layer is pretty much bang on, 0.75. Probably because it was on the table and it wouldn't contract upon itself as much because it's connected to something else. So I bet if we were to print this more solid, it would be a lot closer to the actual thickness of 0.75 inches. Yeah, oh, and then of course, let's see. Oh, that's cool. It's actually bending before it breaks. The tree that does not bend will break. Mulan. Why was everyone so worried about Mulan coming to theaters? I mean, it's a Disney live action remake. It's gonna suck. Who cares? It's not too bad. This was printed in fast quality, so it's 0.3 millimeter layer height. Oh yeah, I see that the best way to do it. So you bend it in one direction and then you bend it in the other, and then that causes the fracture to accumulate. Oh, I did realize something. The box this came in was pretty big, so I'm going to use that for my new 3D printer scrap box. Since there haven't been any conventions, I can't give away my scraps to kids, so I've got a lot of them. All right, so this is the first cube I printed on it. Now this was the one where I used the wrong profile in Simplify 3D. It probably had the wrong Z setting, but then this was done with Cura, and it's pretty good, except for, of course, the bottom of it is a little squished. Let me grab my metric dowel calipers. Yes, I go for max Luddite score by having imperial and metric mechanical dowel calipers. I just do not like digital dowel calipers. I don't know why, I just don't like them. It's like I can eyeball things better with mechanical dowel calipers. Okay, so this is a 20 millimeter cube. It's about 20.16, so it's a little over. But that makes sense actually, because this actually has an infill to it, which means it's probably not contracting as much as our tube did. Because you also got to think this is going to have air going through it, right? So you have a lot of medium, in this case being air, which can sink the heat. All right, it's not too bad. And let's look at the first layer squish. Now I'm sure okay, so first layer squish is about 0.5 millimeters extra. Well, 0.5 millimeters total, which would be 0.25 millimeters per side. I'm sure, like Mayor Makes or Joel, the 3D printing nerd, is watching this video and saying, "Oh, Ben, that's not how you test a printer." And I'm sure it isn't, but I just use 3D printers. I don't test them. I just use them. I don't like test my oil in my car. I just use it. Okay, so here's my chip clip. This, if you notice, I don't know if you can see if that really shows up. I have a flat edge. Just use this. See how that has some curling there? So that part actually lifted off the bed a little bit. The reason why these parts lifted is because they don't have anything on the sides. Everything else has like a continuous line around it, but this is kind of a termination, which means there's nothing past it to hold in place. So if you were printing small parts that were like just the size of this little end piece here, you might actually have some trouble with that. Oh, and this is my chip clip. This is also on Thingiverse. So you just slide it on, works great. Yeah. I'm not really going to bother measuring, because basically there's measurements for everything. Like you can measure the smokestack, and it's 6 millimeters. Yeah, so it's a little under, not too bad. And I'm trying to think what else. This is a measurement 23. It's pretty good. These, they're called like narwhals or narcells. I don't know what they're called. 4 millimeters, it's about 3.75. That's not too bad. But yeah, if you look at the detail, like on the bottom here, let's accentuate it. It's time for art class. Dad made a rubbing of the Grail Diary. They were rats, Dad. Big ones. So what's worse, rats or snakes? Which one do I like less? Probably rats. I mean, I'm not scared of them, but snakes are kind of cool. I used to always like pick up snakes when I was a kid. So yeah, this was after I made the Z a little less squishy. And so yeah, we have pretty good representation of the text there. Really nice, right there you have the, I don't know, the impeller, whatever that would be on this boat. That's actually resolved really well. Then you have your, where the mast would go. And the box is also something. 12, that seems about right. I believe this is 5. Yeah, it's coming up as about 5.6. Let's compare it. I have, when I was doing my Flash Forge printer, which I never made a video about yet, I was dialing in with a bunch of benchies and this pink filament that Joseph Prusa gave me. He's like, hey, you will like this filament. I am Joseph Prusa. I'm from some country. Whatever country he's from, I think he's like the second richest person there now. It's like one of those like weird like fall of the Soviet Union countries. Like there's all these extra countries on the east side of Europe now. Yeah, so I was dialing in the settings. Now again, it's going to look different on camera, but let's see. I'm just going to... there are some things, if you look at like the overhang here. So this, this bench is meant to test a lot of things. Now, we do have a little bit of pocketing, which we don't really have on this one, but if you look at the overhang itself is pretty consistent all the way through, right? Actually, you know what these probably are is the randomized layer changes, because we talked about with this, the layer change in the same place and gave you this line. And normally when I slice, I randomize the layer change, so then you don't have like that obvious seam, right, going through everything. Gives you look at this one, like the text on the bottom. It's a little more squished. See that? A secret that only magic marker can reveal. Yeah, so actually it looks like I have the bed level on the Mega Zero actually set a little bit better than my Flash Forgery. I call it the Flash Forgery because it's the Flash Forge, but then I improved it. Although forgery is not really the right word, because forgery implies that it's inferior, but it's actually better now. Now, if you look at this, I don't know if you can really see it, but there is like a layer deviation, like right here. Can't see it as well on this side. So it is a little less perfect in the slope, although that might not necessarily be a problem with the overhang. It might have been temperature change in the room, something. Although I didn't have the windows open, I just had the ceiling fan going. Can you see that? There's definitely a change right there. But yeah, like the area around the door here, it's not as good on the Anycubic, but it's not bad. There's actually more stringing. If you look at the nozzle, there's some, I don't know if you can see that, like little stringy bits of plastic. Yeah, I would, this is not bad. Obviously, this printed much faster. I mean, this printed probably like 3 times as fast as the Anycubic. I run my Flash Forgery at 9200 millimeters a minute, and it, by and large, that works just fine. Of course, it's using 32-bit CPU. We need to look inside the Anycubic. I'm going to guess that it's using something pretty cheap, like an 8-bit micro. All right, so the Anycubic Mega, it's not very fast, but the quality seems totally decent. All right, I'm curious to see what's inside of this control box. Let's flip it over. Oh, there is a exhalation fan and a nice rubber pad and a decent amount of slots on it. I assume it's going to be... Wouldn't it be funny if they made it not one of these keys, so you know, oh, that'll stop them from opening it. Okay, so predictions. I'm gonna predict, well, it came up on the computer as like a serial converter, so it's probably gonna have, probably not a native USB microcontroller, kind of like an old school Arduino. I think that's also how they did the Maker bot back in the day. It was basically a giant Arduino. All right. Okay, the fan has a disconnect. I can remove that pretty easily. All right. Let's see. Oh, is it actually? Could actually possibly read the brand of the chip. That little chip right there. That is. Oh, man, I wish I could just take this downstairs. How much would I have to unplug? Probably too much. Remember, 0 production values. That's my promise. So I can see this easier on the easier on the camera than I can in reality. What's that say? Well, yeah, that's actually probably like a voltage shift converter for the SD card. If this is just a standard 5-volt microcontroller, what is it? Is it the Atmel logo? Oh, is this just like a little wimpy Arduino? AT Mega 128P. Yeah, 8-bit microcontroller, 128 kilobytes flash, which is actually pretty good for any microcontroller. They probably need that because, yeah, a bootloader probably, I'm sorry, the firmware probably wouldn't fit inside a 32K because it's probably some sort of Marlin fork. I'm looking at the, oh wait, that's Mauser. Oh, I said, wait, I'm off my non-compete. I can say whatever company I want. Mauser, DigiKey, Arrow, Allied, blah, 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 Alibaba Express. Yeah, there's the pinout, and I'm not going to make a still store and put it on the screen. I'll put a still store of Tenet's timeline, but I won't put a still store of this. Yeah, it basically seems like an AT Mega 32.8, but with a lot more flash memory. It doesn't look like there is a USB controller, which is probably why it showed up in Windows as a serial converter device. All right, so yeah, if this is a 5 volt, if it's running at 5 volts, which I'm sure it is, then I'm guessing this is probably the USB converter, and this is probably a line level shifter because SD cards run at 3.3 volts. None of the chips have been rubbed off. There's no unknown blacked out chip stuff. But all in all, it's a pretty simple design. I mean, it's probably too simple. Man, I bet you could fit. What's that thing called that I used? Oh yeah, the Big Tree Tech SKR 1.3. I bet that board would fit in here. I wonder how much better this thing would run. Because when you hear this thing, it's like, it makes all those 3D printer noises. And like my Flash Forgery, it's like almost silent because it has a 32-bit processor with floating point and math. So it can basically move a lot more intelligently and smoothly. So, so it has a name brand microcontroller in it. So, they could have done worse, right? I mean, they could have also done better. What you would do, I would suppose, if you were to rebuild this with a better brain is, you could just ditch this whole box, right? And just take these connectors and hook them up to an SKR 1.3. Oh gosh. Or maybe I should just get a bunch of aluminum extrusion, because all this printer really is probably why it's so cheap. It's basically just a bunch of bog standard aluminum extrusion bolted together. So, I mean, they have some custom pieces this is probably stamped or laser cut steel or aluminum. I don't have a magnet handy. And then you've got this beam in between. But most of it, aside from a few plates, most of it is just, aluminum extrusion. So there's no reason you couldn't build something like this yourself. Even the pillow blocks here, you've got pillow block, that's pretty standard. You got your motor mount, which has a custom piece of metal with minimum bends connected to the aluminum extrusion. So yeah, it wouldn't be really that hard to build this yourself. And then I'm guessing we have some 8mm bearings under there. Those are bog standard. So from an electronics and firmware perspective, this machine is about 10 years in the past. Still, I mean, it's really cheap, and if you wanted, you could upgrade the electronics on this using, an SKR board. You could do it for about, $50-$60. I don't know if it's, it's a solid printer. I mean, that's why I did that with my my Flash Forge. So the first 3D printer I bought, I built them before that, but the first one that I bought was the MakerBot, back when they were made in Brooklyn. And I think I spent $1,700 on that thing, even though it was made of wood. They gave me a discount though, because they're like, "Oh, you're Ben Heck." Yeah. So then the next one that I bought, a bunch of my friends were getting those CTC devices, those, basically the Chinese knockoff of the Replicator 1, because the Replicator 1 is open source. Big mistake. It's open source because they probably didn't want to spring for a patent. If you remember, MakerBot was very rinky-dink in the beginning. That's what people don't realize. It was very rinky-dink. Well, anyway, all my friends are buying these $500 CTC MakerBot ripoffs, and it was also made of wood. I think you get them off Amazon. Oh, that's not good. I don't look how that came off there. I don't 3D print as a hobby. I 3D print for money. So I'm I can justify one of the really good knockoffs, which was the Flash Forge. And basically it's a Replicator 1, except for it had all steel frame. It's really very, very solid. But it never, and I think I spent $1,000 on it, which was, twice as, I thought, oh, this is twice as much as one of these CTC jobbies. So it should be good. But it never really printed that well. And I loaned it to my brother-in-law, but I got it back before he separated from my sister. And but then I upgraded it with I made my own extruder using. Well, I made a new extruder module using the E3D. Well, I guess I could just, instead of talking about it, I should show it. man, I'm so behind on projects. Well, anyway, here's the original extruder or heat block from the Flash Forge. Again, it's pretty much just what was on the MakerBot. But it never really printed that well, so I decided to basically rebuild the entire extrusion assembly. I made this. It has a E3D hot end and heat sink, very nice. A BL Touch auto leveler, so you don't have to worry about the Z switch. It's a little bigger than I would have liked because I kind of designed it in pieces and added on, but it still works. We have a part cooling fan, which goes down there. And then big chunky lever to pinch the material. Oh, it looks like my nut fell off. And then I have a hood here. So you have to keep this extruder motor cool because everything's made out of 3D printed plastic. So if this motor gets too hot, it will actually warp the plastic around it. So there's actually a fan back here. And the only reason there's a hood is so I could pop it open and hit it with my IR gun and see if the shroud was working, which it did. And then I just put everything into the, into the normal piece there. Then I ripped off the front of the Flash Forge. I made my own control panel using the touch screen for the SKR. And yeah, this thing works really well. I'm very happy. So, I had it has a solid frame, so I gave it a good brain and a better extruder. Speaking of 3D printers, I was talking about the build platform with the Anycubic. See, the Maker Gear here, and this is a really nice printer, but the build platform can come that far over, so if you have like a soda or something sitting on the desk, it's like, oh no, it's gonna hit it, right? Or you might have something laying under it, like a pair of headphones or a box, and you're like, oh, is it gonna clear that? I don't know. So I like the footprint of the Anycubic. Even though it has a much larger footprint than this thing, you at least know how much travel is going to be used. Oh, and here are the flexible rack and pinion linkages that I'm using for my next revision mask. See the gear interfaces with it, and then it wraps around the back of your head, and then it has like these nipples to hold bike cable. Should be pretty cool. I am gonna finish that. I've been kind of busy lately. Off subject, I'm starting to get all the Z80 Note kits put together. So I'm probably gonna ship it just with a few parts kind of like set in place in some padded envelopes. So yeah, I'll probably be making a video about that as well here in the near future. Finish this off by taking a look at the extruder box because that was the only part that I thought was a little weak. Looks like it's just not held together or anything. Well, I guess it makes sense because once you put the screws in the top, then it is compressed against the stepper motor. So it just kind of comes apart. All right, so what is with the gear? All right, does that come out? How is this put together? All right, let's unscrew this. This is going to be your arm tension control. Let's remove that. This should come out. Yep, okay. All right, so there we have our, basically they used to call it a knobbed bolt, but those are the teeth that actually grab the filament, right? Oh, that's nice. Look, it has teeth on both sides, so it's not just using like a flywheel. Oh, so these interface. See, it's got a gear interface on both sides. That's actually really nice. Yeah. See, you can see when I turn this, it turns, can you see that? When I turn this, it turns the other side. So it's actually gripping it and gearing it on both sides. That's actually really good. Oh, the stepper motor is engaging with this gear. Oh, that's interesting. Yeah, because that's where the stepper motor shaft would go. All right, well, in that case, I'm not thrilled about the fact that this is a plastic gear, right? I mean, it's doing double duty. It's allowing you to turn it. Okay, so that part isn't super impressive. But the thing that I didn't like was that I was having trouble loading the filament, right? Let me grab a piece of filament. You see, filament's always going to have a curve on it. Even if it's extruded straight, you put it on a spool when it's like slightly warm, it's going to take that shape. And the problem I was finding was that when I load this, let's load the filament in. Now you see the filament has a kind of a curve bias, right? So right there, see how it's not entering the next chamber correctly? I had to actually kind of push it. Right there, boom, boom, boom. Now that's the problem I was having when I was first loading it. And I don't know, it seems like there should be more tolerance there, If I go in the other way, That's a little better. But see, like if I rotate the filament, depending on the curve, so really the best way would probably be down, and then it loads in. So by and large, the film is going to enter in this way, which means it's going to bias this direction and hit that wall. Yeah, see that? I don't really like that. It's kind of disappointing that they have, they have the meshed gears and they're gripping the filament on both sides, but then they've got a metal gear on the stepper driving a plastic gear, which is then driving a metal gear. So that part I don't really like. That's not super great. All right, so I guess the question is, how do we improve this? So probably the easiest way would be to go in and just carve a little bit of that plastic out. The thing is, I guess I could redesign the whole thing, but you'd have to keep this gear ratio, otherwise your extrusion multiplier is going to be incorrect. There's probably a couple things we can do. So we have this Bowden tube adapter here. And so what's going to happen is it's going to basically reduce that down to a 4mm Bowden tube. Actually, I have a spare tube right here, as luck would have it. Oh, that one's been crimped. To uncrimp it. Uncrimp my heart, shut up! All right, so the first thing I would wonder is, actually, here, let's cram this through. So anyway, I would say overall, yeah, I like this printer, except for this part I don't like, because your filament, it's, unless you have like some crazy perfect world where all your, well here, let's simulate that crazy perfect world. It's an ordinary world. All right, so this is my crazy perfect world straight filament, right? So let's put the straight filament through, and gee, what a shock, it goes right through, right? But we don't exactly live in a perfect world. That's my impression of Batman. The real Batman, Batman 89. Vicky Vale. Your character is, you're gonna scream a lot. That's it? Yeah, you're basically just gonna scream a lot. Oh, did you see Indiana Jones and the Temple of Doom? Oh, yeah. You know that character? What's her name? Steven Spielberg's wife. Same thing. You're just gonna scream a lot. Okay. You know how that woman would see like a skeleton or a bug and she would scream? Yeah. Well, you're gonna see one of Joker's goons and same thing. You're just gonna scream. Oh, okay. I'm in. Sounds great. Be careful. Oh, I love that scene in Batman 89 after, she screams and he saves her from Joker's goons, and then there's that pointless scene of them driving the Batmobile through the forest. But it's so awesome. All right. Oh, gee, what a shock. That made it better. Something else we could do, although I'd have to do this on the other end, is, it will go into here, and I've actually done this from other printers. I could actually go in and V out, or almost like kind of like chamfer countersink the inside of the tube, which will also make the filament go in easier. Yeah, I think just drilling that hole wider probably did the trick. So let's do this. Let's simulate really bad filament. So let's take some filament, make it really curvy. Wow, it's really curvy filament. Look at that, mate. All right, so... And again, this is without the gear. So if it works without the gear, it'll definitely work with the gear. Well, it made it through. All right, I think, so yeah, I just drilled that out with, what is it? Drilled it out with a 3mm bit, which is probably about twice the diameter of the filament, and that seems to have improved it. I do have one more comment about this design before I close it up. I don't like how enclosed it is. In my opinion, that would probably reduce its ability to expel dust and, like filament granules. But whatever. $150, right? That's the answer to every question with this. But $150. So yeah, I'm just going to go in here with my knife and kind of carve out the inside of the PTFE tube. Let's see if that makes a difference when loading. Okay, I want to make sure the end of my filament is flat. Mostly is. And the tube here. Open up the grip thing. And yep, goes right through. No problem. It's probably about the only design flaw that I can think of. That whole, they just need to make it a little bit wider. I think that would make it good enough. But honestly, you shouldn't have to struggle because, you know, think about it. You can't see what's inside of this box. So if you're like pushing this through and you're clunking and you're like, you know, like, oh, why isn't it going through? I can't see why it's not going through. You know, that can be confusing for people. So the Anycubic Mega Zero, overall, I'd say, yeah, if you can get it on sale for 140, 150 bucks, it's a heck of a deal. I would totally recommend it. It's not the fastest printer, which is probably more down to the electronics than the physical construction of it. But hey, you could always upgrade it later on with a better 32-bit board. So yeah, even if this is 170, you know, sub $200 printers are usually not very great, but this is pretty nice. I mean, you know, this would have been like a $800 printer 10 years ago or more. So yeah, I would definitely give this a shot. If you want to get into 3D printing and you don't have a huge budget, this would totally get the job done. It wouldn't get the job done very fast, but it will get the job done decently enough. Now I've got all these parts. Normally I would give all these spare parts to kids at conventions, but hasn't been any conventions this year. So I've got way more spare parts than I normally do, and now the box is already half full, but at least it's one box. So hopefully we'll see you at a convention at some point in the future.